Good morning, friends. We talk about this topic, modification of Zbus matrix due to change in the primitive network. The change in the primitive network can be the addition of an element, removal, or change in the impedance of the element. Due to this change, the corresponding Zbus matrix will also change. If the element to be deleted is not mutual coupled to any other elements, then the effect of its deletion is taken into account by consisting an element in parallel to this element, whose impedance is the negative of the impedance of the element to be deleted. If the impedance of the element is to be changed, then connect a link in parallel with this element so that resultant impedance of this combination is the desired value. However, if the element to be removed or the element whose impedance is to be changed is mutually coupled to some other elements, then we follow the procedure given below. E bus is equal to Z bus into I bus equal 1. Equation 1. Now, because of change in the primitive network, which primitive network, the bus impedance matrix becomes that dash bus, and hence performance equation now become A dash bus it's equal to Z bus Z dash bus into I bus. This equation 2, where a dash bus are the new bus voltage. Now suppose we keep the original Z bus but make appropriate change in the bus current of the affected element, such that bus voltage are new bus voltage A dash bus. Then the performance equation 2 becomes A dash bus it's equal to Z bus into I bus plus delta I bus. This equation number 3. Let an element P Q which is mutual coupled to an element rho sigma is to be deleted, or this impedance is to be changed. Then in accordance with equation 3 we get DIK delta IK it's equal to delta I PQ for K it's equal to P. Delta IK it's equal to minus delta I PQ for K it's equal to Q. Delta IK it's equal to delta I rho sigma for K it's equal to rho. Delta IK it's equal to minus delta I rho sigma for K it's equal to sigma. And delta IK it's equal to 0 for remaining passes. Similarly, in order to calculate the element Z bus Ij for the modified bus impedance matrix Z dash bus, we connect a current source of 1 pu at the J bus Ij it's equal to 1 pu and keep other bus open circuit. Then we have Ij it's equal to 1 pu, Ik it's equal to 0 for K and for K it's equal to 1 until N. K it's not equal to J. Then from the equation 3, this equation 3, we have a dash I it's equal to summation from k it's equal to 1 to k it's equal to n, zik it's into ik z plus delta ik. This equation 6. Substituting equation 4 and 4 and equation 5 in equation 6, we get this equation. It's equal to f dash I, it's equal to zij plus zip minus ziq into delta ipq plus zi rho minus zi sigma, it's into delta I rho sigma. Let's make this alpha it's equal to matrix P rho, and alpha beta it's equal to this matrix Q sigma. Then by defining this new variables, equation 7 takes the form E dash I it's equal to Zij plus Zi alpha minus Zi beta into delta I alpha beta. It's equation number 8. Let Ys is the primitive admittance matrix of the original network, and Y dash S is that of the modified network. Then the performance equation of the primitive network in the admittance form due to this change will be delta I alpha beta is equal to Ys minus Y dash S into V dash gamma delta. And V dash gamma delta is equal to A dash gamma minus A dash delta. And A dash gamma it's equal to Z gamma J plus Z gamma alpha minus Z gamma beta into delta I alpha beta. And the same for A dash delta. This equation. Substituting equations 11 and 12 in equation 10. And we get this equation number 13. Substituting equation 13 in equation 9, we get this equation and this, and the rest delta I alpha beta it's equal to Ys minus Y dash S is into Z gamma J minus Z delta J, and so on. We get this equation, and the end Ys minus Y dash S into Z gamma J minus Z delta J is equal to M power minus 1 delta into delta Ys into Z gamma J minus Z delta J. This equation number 16, where M it's equal to U minus Ys minus Y dash S into Z gamma alpha minus Z delta gamma delta alpha minus Z gamma beta plus Z delta beta, and delta Ys is equal to Ys minus Y dash S. Substituting equation 16 in equation 8, this equation 8, we get this equation A dash I it's equal to Zij plus Zi alpha minus Zi beta it's into M power minus 1 into delta ys into z gamma j minus z delta j. Since ij it's equal to 1 pu and the rest of the paths are open circuited, the modified path impedance matrix Z dash paths will be found as follow. Zij modified it's equal to Zij plus Zi alpha minus Zi beta it's into m power minus 1 into delta ys into z gamma j minus z delta j. It's equation number 18. For I it's equal to 1 to n and j it's equal to 1 to n and this all thing. Thank you.